All right, welcome to Dilemma's Concepts. What we're looking at in Algebra 1 is we're still looking at exponents, and we want to look at how do we prove that 2 raised to the 3x plus 5 is equal to 32 times 8 raised to the x. All right, so first thing what we want to do is to take into consideration the laws of exponents, right? So the moment I see that we have 2 raised to the power of 3x plus 5, it's going to tell me that I was actually multiplying the same base. So in other words, then this can be written as 2 raised to the 3x times 2 raised to the 5. So if you want to think of it in reverse, if you want to think of what if I had this, if I would be able to get this from it. And if the answer is yes, then you would have realized that you would have made a correct step, right? So remember now we're taking this here and we're going to break it down and produce this. All right, so let us see where we are. Now, what's going on here is that I could take this and let it be a number. So that's 2 raised to the 5th power, which technically means 2 times 2 times 2 times 2 times 2, and this is 32, right? So this part becomes 32. And I'm going to put it out front as a coefficient, basically. So I'm going to have 32 in front of 2 raised to the 3x, right? Now, please remember that the power of power will give me some privilege here where I can actually um, flip those like it's commutative. I could turn them around. For example, all right, I'm going to let this 32 stay up front, and then I'm going to switch this as 2 to the third, then raise it to the x. Because the power of a power um, gives that opportunity. For example, if I have 2 to the 3x, it is the same thing as saying these 2 to the third raised to the x, or I could have written it as 2 to the x and raise it to the third. So I'm able to, if I have the exponents multiplying up there, I'm able to put one set in the parentheses and switch them around. So basically, we're back at this. So this is actually 32, and 2 to the third is going to be 8, and it's raised to the x. And with that said, we have just proven that. All right, so let's take a look at this other one here. So this other one, what we require to do is that we want to take 27 raised to the 6a minus 1 and let it equal to 3 raised to the 6a in parentheses to the third all over 9 times 3, right? All right, so let us take a closer look. Remember, the fact that I'm seeing here, I'm seeing a subtraction. It would suggest that I would have the same base being divided. So I could take this and rewrite it as 27 raised to the 6a divided by 27. So basically, what I'm saying is if I'd gotten this, would I be able to write it like this? If the answer is yes, then yes, we would have made the first step correct. What we want to do is to put things in the perspective that we ought to. For example, I'm seeing here where the 27 is represented as 9 times 3. So I'm going to do that for my denominator. So 27 here will now be written as a 9 times 3 right there. But let's take a look at the numerator. I'm going to rewrite 27 using a base of 3. For example, this is 3 to the third, and that is my 27. And then I'm having 6a outside. So I just represented 27 here, right? As 3 raised to the third, at 3 times 3 times 3. 3 times 3 times 3 is 27. So I just represented my 27 like that. Now, now I'm going to apply the power rule because I'm able to take these, the power for power, and I could interchange them to suit myself for example, I'm going to let this be 3, and I'm going to switch the 6a come inside, and then I'm going to have the 3 on the outside, and that's my numerator. And I'm still having 9 times 3 underneath. And there it is. I would have taken this and then show that I could prove that it is the same thing as that. All right, let's do the last one. So I'm going to prove that 2.1 raised to the 3x plus 1 is equal to 2.1, and in bracket I'll have 9.261 raised to the x. So we're going to use the laws of exponent to do that. Again, I'm going to take a look at my exponent. So my exponent is up here. The fact that I'm seeing addition, it means that I was actually multiplying the same base. So I'm going to take this 2.1 raised to the 3x plus 1, and I'm going to break it apart. So I'm going to rewrite that as 2.1 raised to the 3x times 2.1 raised to the 1, right? So as you could see, I could put these in a bracket if I want, right? So basically, what I do have is that we're noticing here that I have actually take the first step. I split apart the 3x plus 1 because the plus would indicate that I was multiplying by the same base. I could take this and put it in front, right? So I'm going to do that. So now I have 2.1 raised to the first power is the same thing as 2.1, right? So I have that there. So the next thing that I actually have 2.1 raised to the 3x. But if you notice what I have to do, I need to create this number, and then I need to have an exponent of x. So I'm going to split this one more time. So I'm going to split this, right? So I'm going to utilize the power of power and split that. So this is what I would have now. So I'm going to have 2.1, and then in the bracket, I'm going to create this where I'm going to separate the x and the 3 here. So I'm going to raise this to the third, and then I'm going to keep the x on the outside. So now I'm going to find the value of this. So if you want to double check with me, you could check quickly. So it's going to be 2.1 times 2.1 times 2.1, and it's going to give me 9.261. So if I rewrite this is what I have, 2.1, and in bracket or parentheses, I'm going to have 9.261, and that will be left to the power of x. Hence, I have just proven that.